Okay, let's look at finding discontinuities algebraically, and specifically in this case with a rational function. So the first thing you want to do is you want to factor the numerator and denominator, because what's happening is that anything that cancels where you have the same binomial or same term, that means that that's a hole in the graph because it's giving you 0 over 0. And then what remains in the denominator is creating a number over 0, and that means that's giving you a vertical asymptote at that point for x. So let's go ahead and look in here. I can factor out 2x, right, from both of these. That's going to leave me with x minus 2. And down in the denominator, I have x plus 4, and x minus 2. So if I look here, right away I can see x minus 2 cancels out, right? So the x minus 2 cancels out, and that means that the hole is not at negative 2, but x minus 2 equals 0. So the hole is at x equals 2. Notice it's 2 because if I input 2, I get 2 minus 2 is 0 over 2 minus 2 is 0. So I get a 0 over 0, and that's how I know the hole is at x equals 2. And remember, that is a removable discontinuity. Okay, and then the next one is if I look here, well, what's giving me a 0 in the denominator when we have x plus 4? Well, x plus 4 equals 0, so it's always the opposite of what you see there is x equals negative 4. So that means there's a VA. So there's a VA at x equals negative 4, and that is a non-removable discontinuity because it's not something that you can take out of the graph, but a hole is like you're removing a value. Okay, let's do the next one here. So if I look at this one, I notice I have x minus 5 and x plus 2 is how I'm going to factor this numerator. Notice we're thinking about negative 5 times 2 gives me negative 10. Negative 5 plus 2 gives me negative 3. That's how I know I factored it correctly. And down here we have a difference of squares. So that's going to be x plus 5, x minus 5. So notice what cancels here. We have x minus 5 over x minus 5 cancels. So that's where the hole is. And it's always at the opposite of what you see inside the parentheses, because we need what's going to give us 0 over 0, and that means that there's a hole at x equals 5, and again, that is removable. Then the next thing we do is we look here, we see x plus 5 is giving me, when that's negative 5, that's creating a VA. You always want to do the hole first because you won't, that way you don't mistake a hole in the graph for a vertical asymptote. So now x plus 5 equals 0, while x equals negative 5 is the x value where we have a vertical asymptote in this function. So that is, again, non-removable. And now we're done with that one. Let's look at one more where something a little different happens. Okay, so we're going to go ahead and factor again, like we've been doing for the other ones. So if I look at this, well, what multiplies to negative 28? Actually, we need to fix this. This should be, let's fix this right away. Just do this in real time. Let's make that negative 24. That's going to work a lot better. So if I look at this, x plus 5x minus 24, well, that means I got x plus 8, x minus 3, and that is over x plus 6, x minus 2. Okay, so once I look at this, right, I have an issue. Well, nothing's going to cancel out, right? So what that really means is that there's just no hole in the graph. And instead, you're going to have two VAs. So if I look here, I got 2 points that are going to be a vertical asymptote. So we got a VA at x equals negative 6, and that is non-removable. That'll never change. It'll always be non-removable. And then we have another one, a VA at x equals 2, and that is also non-removable. And you don't really even have to state it, because if there's no hole in the graph, you don't have to state it. And now you're done with this one.